Hi students, welcome to our chemistry class. Today we are going to start new chapter and its name is acids, bases and salts. In this chapter basically we are going to deal with different types of acids and bases. And in today's class we are going to just start this chapter by talking about some of the introductions and all. In your previous classes, that means in your 7th standard and all, you studied this chapter about acids, bases and salts, the same name for the chapter. And now I am just recalling some of the things you studied in your previous classes. In my hand I have lemon juice, vinegar and baking soda. Baking soda solution. So I have three different types of things. The first one is lemon juice, vinegar and baking soda solution. Now when we are tasting this, what is the taste of this? For the lemon juice and the vinegar, the taste is sour and we call this as acid. That is the things that taste so we can say it as acid, and when we are tasting this we feel it as bitter and we can say it as base. This is only a general type of classification. So we can identify the acid and base. If it is possible to taste, then it will be like this. Now, one person is here and he is facing acidity. And in my hand, I have 3 beakers and filled with lemon juice, vinegar and the baking soda solution. That means this is acid, this is also acid and this is base. Now this person wants to reduce the acidity. What he will do using this? In his hand there is only having these 3 solutions. So what he will do? He will select the baking soda solution for reducing the effect of acidity. For example, if he is again drinking this lemon juice, then what happens? Here this acidity means there is having excess amount of acid is there in his stomach. So when he drink this lemon juice, then what happens? Then increase the amount of acid in his stomach and then he will get into trouble. And so when he is having this baking soda solution, what happens? Then actually there occurs what? The effect will nullify. That means when this acid and base are adding together, what happens? The effect of acid will get into nullify. That means they are getting cancel each other. We will simply say it like that. It will get cancel each other. And in your previous classes, you gave this process a name. Will you remember that? The name is this neutralization. Neutralization. So, neutralization is the process of cancelling the effect of acid and base together when they are getting react together. That is what neutralization. Now, we are going to define this term neutralization. Neutralization. We can define this neutralization as the reaction between acid and base. The reaction between acid and base is called neutralization. When this acid and base react together, what is the product we get? We get the product as salt and water. We get the product as salt and water. And when we are combining a particular type of acid and base, then we get a particular type of salt. And the type of salt is getting depends upon the selection of the acid and base. And also here one product is the evolution of heat. That means in this reaction they produce heat. When we touch the test tube, we feel the produced heat, and we can say this reaction is exothermic. Exothermic reaction. So, you can write this acid plus base gives salt plus water. This is the general equation. General equation for the neutralization. When acid and base react together, we get the product as salt and water and they evolve heat. And now we are going to look one example. When hydrochloric acid is getting react with sodium hydroxide, then we get the result as sodium chloride plus water. So, this is what the reaction. That is, when the hydrochloric acid HCl is getting react with sodium hydroxide. When this hydrochloric acid is getting react with sodium hydroxide, we get sodium chloride. We get sodium chloride and water. This sodium chloride is what? This salt and this is water. And also they produce heat. This is one of the example for the reaction with the neutralization. Just remember this example. Now we are moving to the next topic. Here at the initial stage we said that we identified the acid and base by tasting that. But is it possible to taste this HCl or sodium hydroxide like the things? Is it practical? Obviously no. So the tasting is not a proper method to identify is it acid or base. And that's how we define another thing, that is indicator. Indicator is a substance that we are using to identify a particular substance is acid or base. So, the indicator is a substance that we are using to identify a particular substance is acid or base. So, that is the indicator. There are different types of indicators. In your 7th standard, you studied about natural indicators. Natural indicators. This natural indicators means the indicators that we are getting from the nature itself. And the other type of indicators are there, that is the synthetic indicators. Synthetic indicators means that we are synthesizing, that we are preparing chemically in laboratories and all. That is what synthetic indicators. Synthetic indicators. And you want to study the examples also. And also there is having another indicators also like the universal indicator and olfactory indicator. Like different types of indicators are there. Now we are going to study natural indicators first. There are different types of indicators are there. We are using indicators to identify a particular substance is acid or base. So the natural indicators are there, synthetic indicators are there, universal indicators are there, olfactory indicators are there. These are different types of indicators. We will explain these all later. Now we are going to explain natural indicators. Natural indicators means the indicators that we get from our nature. So the first one is the litmus. Where we get this litmus from? We get this litmus from lichen plant. We get this litmus from lichen plant. Or we can say it as we extract the litmus from lichen plant. Then we are talking this litmus. We have two different types of indicators we can prepare from this litmus. That is litmus solution and litmus paper. That is, there are two types of indicators we can make from this litmus. One is litmus solution and other is litmus paper. This litmus solution is something in liquid form and this litmus paper is in solid state. So actually the result is also different for this. Now we are going to look what are the things that is giving from this litmus solution and this litmus paper. For this litmus solution, first we are talking about litmus solution. Generally, that means normally this litmus solution is having the color purple. Purple means something like pink. So, for this litmus solution, normally its color is purple. When we are adding acid, this purple color will turn into red. This purple color will turn into red when this litmus solution is getting react with acid. And when we are getting react this litmus solution with base, what we get? We get it as blue color. That means this purple color will turn into blue. And what about the neutral? For the neutral solutions, we get when we are reacting this neutral solution with litmus solution, what is the color? The color will remain as the purple itself. So, here we are talking about what color will occur or what color change will occur for this litmus solution when we are adding acid, base and neutral. So, for acid or acidic solution, it is giving red color. You want to remember this. And for this base, the color, this purple color will turn into blue. And for the neutral solutions, there is no color change occurs and the color will remain as purple itself. So, this is the color change for the litmus solution. Now, we are going to discuss about the litmus paper. Litmus paper. this litmus paper, we have two different types of litmus papers, that is red litmus paper and blue litmus paper. And you are always getting confused with the color transformation with the red litmus paper and blue litmus paper with the interaction of acid and base. So, I am just giving you one code to remember, that is B, R, B and A, B, R. When you remember this code, you will easily identify the conversion of the color. For the base, red litmus paper will turn into blue. For the base, red litmus paper turn into blue. And for the acid, blue litmus paper turn into red. And in this case, for the base, what about the blue litmus? It will remain into the same color. No color change will occur. And what about the acid in the red litmus paper? No color change will occur. So, when you remember these codes, you will easily identify the color change with the acid and base. So, for the base, red litmus will turn into blue, and for the acid, the blue litmus to red. So, this is the color change for the litmus paper with the interaction of acid and base. This is a type of natural indicator. That means this litmus we made from one natural plant called lichen. So this is one of the natural indicator. Now we are going to study which are the other types of natural indicators. Red cabbage. Red cabbage leaves. This is another type of natural indicator, red cabbage leaves. We are using this to identify a particular substance is acid or base. The other one is turmeric. Turmeric. For this turmeric, when this, normally turmeric have yellow color, when this turmeric is getting react with base, what color occurs? The color will change into red color. Red color. So, we can say it as this turmeric is a natural indicator, and for the acid there is no color change will occurs. The other one is China rose petals. China rose petals. That means China rose petal means the hibiscus flower. This also we are using as an indicator. So, this is also what? Natural indicator. You just want to remember these examples. Litmus, red cabbage leaves, turmeric, China rose petals, etc. These are some of the natural indicators. Now we are moving to the synthetic indicators. Synthetic means we are creating it from the laboratory, or we are making it chemically. That is synthetic indicators. Synthetic indicators. Now you want to study the examples for these synthetic indicators. The examples are these: phenolphthalein, phenolphthalein. This is one of the synthetic indicator. The other one is methyl. Other one is methyl orange. So these are the two examples for synthetic indicator: phenolphthalein and methyl orange. The color difference we will discuss later. So now you just want to remember the names of this phenolphthalein and methyl orange. Now we we are going to study the chemical properties of acid and base. Chemical properties of acid and base. In this area, I am just giving some of the acids, base and their chemical formula. You want to study the chemical formula and name of these. So the first one is this HCl. What is this? Hydrochloric acid. Hydrochloric acid. The next one is H2SO4. H2SO4 is sulfuric acid. HCl is hydrochloric acid. H2SO4 is sulfuric acid. The next one is HNO3. Nitric acid. Nitric acid, HNO3. The next one is CH3COOH. CH3COOH. What is the name? This is acetic acid. This is the acetic acid. So, these are the 4 different types of acid. You want to study the name of these acid and also the chemical formula of this. Now, we are going to study the names of base. The first one is this NaOH. What is this NaOH? Sodium hydroxide. Sodium hydroxide, NaOH. The next one is this CaOH twice. This is calcium hydroxide. CaOH twice, calcium hydroxide. The next one is this KOH. What we call this? This is potassium hydroxide. Potassium hydroxide, KOH. The next one is MgOH twice. This is magnesium hydroxide. Magnesium hydroxide. The next one is this NH4OH. This is ammonium hydroxide. Ammonium hydroxide. So, these are the examples for the acids and bases. Now you can see at the board, these are what? Bases. So, acids and bases are here. And when you observe this, you can see in the chemical formula, here we have OH. OH. This OH is in all this chemical formula, and also you can see this OH means the hydroxide. This hydroxide is in all these names. So when you see this hydroxide in the chemical name, you can say it is base. So we can say for the base, in its definition, we can say it is having but OH minus ion. Now you just focus here. When they have OH, then we can say it as base. And you want to study the names and also the chemical formula. Then only you can write the equations and all. Now, we are going to do one experiment. That is, I am just showing here one sample. That means I am just doing this experiment using one acid, one base, and also I will show the result for water. Then you want to complete this table using the other acids and bases. And you want to do it in your lecture note. And this is one of the homework for you. So, I am just here showing one example here. First column is sample. Red litmus. Blue litmus. Phenolphthalein. And methyl orange. So this is our table and we are checking what result we get when we are adding acid to this. We are adding base to this. And when we are adding neutral to this, what result we will get. That is the thing we are going to look here. The first we are checking this with HCl, hydrochloric acid. First we are checking this with acid. The result is like this. When we are getting react this red litmus paper with acid, we get the result as remain red itself. For the blue litmus, it turns to red. For this blue litmus, it turns to red. And for this phenolphthalein, it remains colorless. That is, for the acid, the phenolphthalein give colorless acids result. And here you can see methyl orange. And you can see generally this methyl orange is having yellow color. And that yellow color is getting turned into red when it is getting react with acid. So for this acid you get the red litmus remains the same color. For the blue litmus, it turns into red. This blue turns into red. And for this phenolphthalein, it remains as colorless. At first, it is colorless, and when it getting react with the acid, then also the color is having no change. And what about the methyl orange? Generally, it is having yellow color, and when it is getting react with the acid, then the color turns to red. So this is for acid. Next we are talking about base. Base. So for base I am selecting sodium hydroxide. Sodium hydroxide. So when the sodium hydroxide is getting react with this red litmus, this red turns into blue. Red turns into blue. And what about this blue litmus? The same. No color change will occur to this. That is when the base is getting interact with the blue litmus paper. No color change will occur and that will remain in blue color itself. And now the question is, what about the phenolphthalein and methyl orange? For this phenolphthalein, the initial stage it is having no color, that is colorless. Then when it is added with this sodium hydroxide, the color changes to pink. Its color changes to pink. And here when this sodium hydroxide is getting reacted with methyl orange, the color is yellow. Yellow means normally this is having yellow color and so we can say it as there is having no color change. This is about the sodium hydroxide. That means the base. For the base, for the litmus, this red will turn into blue. Blue remains as blue itself. And for this phenolphthalein, the colorless solution will turn into pink and the methyl orange is in yellow color. Now we are checking this with water. You know this water is neutral. So what about this? The red litmus paper have any color change? No. It remains in red color itself. And what about the blue litmus? It is also in blue color. Now the the question is, what about the phenolphthalein and methyl orange? For this phenolphthalein, generally it is having colorless, and so for this water, it is also again colorless. And also, generally it is having yellow color, and for water also it is having yellow color. These two things you are familiar already, and the new thing you are studying about the phenolphthalein and methyl orange. So we are concluding this table as, so in the similar manner you want to complete this table using the other acids and the bases. I already gave the names. So you want to fill this table in your lecture note. Now I am going to conclude this. That is the color change of the phenolphthalein and methyl orange. It is like this. For the phenolphthalein, ACBP. That is, for the acid, it is colorless, and for the base, it is in pink color. So, for phenolphthalein, ACBP. When you just remember this code, it is easy to remember. ACBP means for acid, it remains colorless, and for base, it is having purple color or pink color. That is about phenolphthalein. And what about the methyl orange? For the methyl orange, you want to remember ARBY. ARBY. This means that for acid, the color turns to red, and for the base, the color is yellow. For the acid, the color is red, and for the base, it is yellow. And for the neutral solutions also, it is also having the yellow color. And what about here phenolphthalein? Here also, for the neutral, it is having colorless. That means generally what is its color? That is the result for the neutral solutions. So this is all about this phenolphthalein and methyl orange. You want to study the color change without any confusions. You will get the questions like this. What is the color change occurs when we test this acid with this indicator phenolphthalein? Like the questions will come. So you want to study the change of the colors without any confusions. Now, a small area is also left in this area, and that is about another type of indicator. First we discussed about natural indicators. Then we discussed about the another type of indicator, and that is synthesized indicator. And next we are going to discuss olfactory indicator. What is this olfactory indicator? It is also a type of indicator. Indicator means we are using certain type of substance to identify is it acid or base. Now the question is, what is the difference with this olfactory and the other type of indicators? This olfactory indicator is a type of substance which or whose odor changes with acid and base. That is, here change occurs with odor. What about the natural indicators like the litmus? There the change occurs with the color. Here the change occurs with the odor. Odor means smell. So this is what olfactory indicator. Olfactory indicator means the substances whose odor change with acid and base. Which are the examples for these type of indicators? The examples are these: onion, then the other one is vanilla essence, and clove oil. These are some of the olfactory indicators: onion, vanilla essence, and explain how to make this onion as olfactory indicator. And also we are using this onion as one indicator as a liquid, that by we are just boiling this onion in the solution of water. Here we are not talking like that. We are just taking this onion and making the olfactory indicator by very simple method. Just take a piece of onion and just make it into pieces. Then take a polythene cover and put this onion in this cover. And also put some pieces of cloth in this. Some small pieces of cloth in this and tie it for one night. That means we just kept it for overnight. And after the day, you just take the cloth pieces and you can use these strips of cloth as olfactory indicator. That means, for example, when you use this to the acid or when you interact with this to the base, you will get particular result. Now, this is how we are making the olfactory indicator using the onion. It's there in your textbook. You please want to read it. Now, a small portion is there left. That is the output we are getting using these three type of indicators. Indicator, acid and base. Indicator, acid and base. The first one is onion. Now the question is, what is the change for the smell will occur? That is the question. So, we already prepared the olfactory indicator using the onion. So, when we are interacting that indicator with the acid, what happens? The result is like this. Generally, for the onion, it is having certain type of smell. And for this acid, there is having no change for the smell. No change for the smell when this onion is getting interact with acid. And what about the base? When this onion is getting react with the base, when this indicator is getting react with the base, then it loses the smell. Loses the pungent smell. So that's about the onion. The next one is vanilla essence. For this vanilla, it is having generally a sweet smell. So, for the acid, there is also having no change for the smell. No change for the smell. When this vanilla essence we are adding to hydrochloric acid, what happens? The vanilla essence do not change its smell. The same will remain. So, we can say it as acid. And when we are adding the base to this, it loses smell. Now we are discussing about the clove oil. Here also the result is same. When this clove oil is getting react with acid, no change will occur to the smell. This clove oil is also having a particular smell. That smell will remain same with the acid, and when we are interacting this base with the clove oil, then it loses the smell. So this is the result for the indicators and the interaction with the acid and base. The next topic is reaction of acid and base with metals, and we will discuss it in the next class. So today you have one work. You want to complete that table with all the acids I give and also with the base. So this is work for today, and you want to read the textbook, and also you want to read the textbook in the 7th standard, the chapter named Acids, Bases and Salts. That will help you to catch all these things very fast. So it's enough for today. We will meet in our next class.